Hello, everybody. We should be ready to go. There we go. How's everybody doing today? It's good to see so many of you came out. My name is Brandon Savage, as she said, and I'm here to talk about data abstraction in large web applications. A little bit about who I am when I'm at work. I work on the development team at Mozilla, the web development team on the Socorro application. And Socorro is the crash reporting application for Firefox. It's where all your crashes go when you actually submit them to us. I'm also the author of the PHP Playbook, which is a book about basically how to work as part of a development team. I used to blog pretty regularly. I haven't blogged as much as I like or probably should, but you can find me online. And then I'm a private pilot in my spare time, which is a lot of fun. And there's a nifty little fact about me that I like to share. And it proves that I'm human. So the title of this talk, and I've bolded the important word here. This talk is about data abstraction in large web applications. But the important thing here that I want to emphasize is that if you're looking for a magic bullet or an easy solution to make your web application large or to solve a particular problem that you have, this is probably not for you. I don't have any magic bullets. What I have for you is my own experience in working with web applications, in working with Socorro, in working with other applications for other employers that I've learned over time. It helps solve some of these problems that we face. And what I'm going to talk about is not so much how to necessarily organize your code, but some of the things you want to look for as you're building your applications, as you're moving forward as a developer. Because as I've found out very quickly, though my application may be database focused to start, it rarely ever stays that way. So a little bit of history here for you. A long time ago, when the web was young, and most of us were probably learning PHP, maybe in version 3 or version 4 of PHP. Most of us created our web applications using a database. I know I did. My very first web application was an online role-playing game. It was the greatest thing I thought I had ever built until someone actually put data in it and it all disappeared because I hadn't escaped the quotation marks. So a long time ago, we all used the LAMP stack, and the web was very small and it was very young, and databases could support basically everything we wanted to do. But the web got bigger, and the problems got more complicated, and we came up with new ways of storing data and accessing data. So we came up with things like SOAP, and we figured out that was a bad idea, and so we moved to REST. And we have NoSQL databases now, and we have Redis and Elasticsearch and Memcache, which, yes, is a data store. All of these things came along to help us with our problems, and a lot of them came along out of necessity. Something like Facebook came along and got big and needed to solve some of these problems and figured out one database server wasn't cutting it, so they came up with another one, and then all of those things came along. But for some reason, when we build our web applications, when we start from the ground or we take a look at the web applications we have, for some reason they start and they act like the database is the only data source they're ever going to have. And this is an interesting problem. Maybe it's because that's how we all started. Maybe that's because setting up a database is second nature to all of us. But for whatever reason, we act as though the database is the only data store we're ever going to have. And that's how we write our web applications. That's how we write our models. And this creates a problem for us as we move along. And so this talk is about changing our thinking, because databases aren't it. There are other options available. There are other things out there that we can use and that we are using for data storage. So I want to talk a little bit about where I'm coming from, the experience that I've had that has kind of informed this talk and kind of formed the thought process that I'm going to share with you today. As I mentioned earlier, I work on the Socorro application for Mozilla. So Socorro is this web app that has 5 web heads and something like 100 other servers that back it up in various ways. And Socorro, when Firefox crashes and you submit that crash report, we receive that crash report. It doesn't go off into the ether, never to be seen again. It actually is received and processed. We process anywhere from 10 to 20% of crashes of a release, and then any crash that has a comment, we process those 100%. So if you ever want to make sure your crash report, you include a comment in it about what you were doing. But in Socorro, we have a whole bunch of data storage options. We have some 3 to 5, I believe, terabytes of data. I'm not sure exactly how much it is, but it's a lot. And we have, in Socorro, we use Postgres as a database. We have a REST API middleware. Okay, that's a data source. We use Elasticsearch to search because it's really fast. It's written in Java, but we don't really care because it solves a problem. We have HBase to store processed and unprocessed crash reports. Okay, we interface with Bugzilla, so when a crash report comes in, and we figure out what the signature of that crash report is, we want to know, have we filed a bug against this? Have we already fixed this problem and the user hasn't upgraded? Is this a new problem that we don't yet know about? So we have an interface with Bugzilla that'll pull that information in. And then we have Memcache, which most people think of as caching, but it's still data. We still store data somewhere. And so I think it counts, personally. And this is just for the web front end. This doesn't include the data sources, which are all of you that use Firefox. You send us data through the collectors and through the information you provide in your crash report. So that's another data source that I'm not even going to touch on because it's really out of scope for this talk. But the thing is that Socorro was written as a database web application. Originally, we just had Postgres. And it was written that way. And that's the framework we used was an early version of Kahana, and that's how we wrote this application, is to use Postgres. And we figured out pretty quickly as we've grown, as our data has increased, as we've been given more money and more tools by the company because this is an important product, the database-centric model, it doesn't work anymore. It doesn't solve the problem because we have too much data and we have too many sources of data and we have too many needs for this application to use just a database. Postgres has worked great for us for a long time and we still use it, and it's what powers most of the web front end, but it's not enough anymore. So how do we solve this problem? I think there are 4 things that we can do as developers to solve the problem of abstracting our applications from the data source, in building applications that don't necessarily rely on a given data source. Okay? The first one we can do is we can separate the use of the data, where the data is used, from the retrieval of that data, where the data is stored. And this might seem self-obvious and self-evident, but I see so many applications that don't do this, my own included. Okay. The second thing I think we can do is we can start thinking about our models not in terms of getting data out of a database, but in the actions we're trying to do. We're trying to create users, store users, retrieve transactions, those kind of things. Third, I think that we should be building our applications to be data source agnostic, and this kind of goes with the first point on this list. If we are building our applications to be data agnostic, they don't care where the data comes from, and this makes our lives a whole lot easier when we have to care, when we have to change the data source. And as your application grows, and as ours has grown, you will have to change the data source. And fourth, it's very, very important to use the correct storage medium. There's a lot of discussion. There's a lot of cool new things out there. NoSQL databases are cool right now, or at least they were last year. Are they still cool? We have Elasticsearch, Redis, all these things out there. Some of them are hot and cool right now. Some of them are old technologies like the database. And we have to know and use the correct tool to solve the correct problem. And it's odd how often this step gets skipped is by people who think, I have this new cool thing and it solves all my problems and I'm going to use it. And they don't realize it doesn't solve the problem that they have. And instead, they're eating the marketing, basically, of whatever it is. And I've seen this on my own team. I've seen this in other teams. So I wanted to emphasize this as kind of my last point. So let's talk about the specifics of these 4 things. So large web applications like Socorro, it's not an art form to abstract our data retrieval from our data use. If we don't do it, we have serious problems in maintenance. We have serious problems in stability. And it makes it really difficult for our users. Socorro is actually used by a bunch of gaming companies to collect crash reports from their games and to process those. And they don't, they're not building Firefox. They're building Minecraft or something like that. They don't care about the Firefox release model. So they want to use different data sources, and some of them hate HBase and don't want to have anything to do with it. So for them, it's really important that we do this, that we give them the option of building other things. Most people here are probably have seen this, code in a controller where you're pulling something out of a database, and most of us know this is bad. This is not model view controller. This is a collection of PHP code that really doesn't, that's not abstracted. It doesn't have the proper level of abstraction. And most of us solve this problem by doing this, by abstracting out the SQL query from the controller, leaving the controller simply to get the information and to display it to the user. The problem is that this is still wrong, because not only are we pulling the data out of the database, but then we're processing the results, and that's what this is right here, this process results. I didn't want to give you a slide full of code. It doesn't really show anything. But this is still wrong. And the reason this is wrong is because you are eventually going to have to come back someday and change that from a SQL query to a REST API call. And then all of a sudden, all the assumptions you made about how to process that data are wrong, and you have to rewrite the code. And so basically, you're rewriting a third, if not more, because your models are probably bigger than your controllers, of your application. I've been here. I've done this. It's not fun. So the takeaway here is that processing the data has to be a separate layer. Once we've gotten the data, we have to send it to be processed and dealt with and worked on differently, in a different layer than the actual retrieval. And this is what we started to do with Socorro. We've decided everything's going into a middleware layer, a REST API middleware. It's going to return JSON. That JSON is going to be processed by PHP into whatever format we need to produce the report, but we aren't going to process it in the middleware. We're simply going to return the data. So our middleware is Python, but this is a PHP conference. So let's talk a little bit about what it is that I'm after here. I prefer to use two steps in a model, and this is abstraction within the layer itself. The first one is to have your data model, which models whatever it is that you're modeling. And then it uses an adapter. And this adapter, all it does is take inputs, find the data, and return the data to the user in some commonly agreed upon format that can be used. And the benefit of doing this is that it makes swapping out your data sources really easy. If we had done this in Socorro, we wouldn't have the problems that we do, because we would simply be able to say, oh, we're moving to REST, drop the SQL queries, put in the REST calls to the API, make the data into whatever common format we've agreed on, send it back, problem solved. So there's a cautionary tale that I like to tell when I'm talking about this that has to do with swapping out data sources. 'Cause this happens all the time. I found that this is a common problem that I've had in just about every role, and Socorro isn't the only application that this happens in. One company I was working for, we had another REST API, and we wanted to use this REST API to get data about emails that we were sending. And we were storing everything in the database, but we realized we needed to have only one, we needed to build the structure in such a way that we wouldn't have to write the code more than once, because we were essentially doing the same thing in two different places, in two different ways, and that wasn't working for us. So because it was written in PHP, I could simply include the files, and since it was a REST API, I decided to call the protocol. I came up with NAP for not a protocol, but I figured it fit with the REST theme. The problem that I had is that the model was built in such a way that I essentially had to rewrite half of what I had already done. And this was a huge undertaking, because it was the whole core of the application. And if I had simply separated those two like I did when I rewrote it, I could have changed from accessing the database to accessing this REST API and not given it a second thought. It would have taken me half a day instead of the 3 weeks that it actually took, because I had to essentially rewrite my application. And we're going through the same thing, like I said, with Socorro, where we have a guy whose whole job right now is to pull SQL queries out of Socorro and put them into the middleware. That's his job. And he has to go through and pull the SQL query out and rewrite the processing rules and build this middleware service. And it's a Q1 goal for us, so that ends basically end of March. But so this is what he's doing. And it wouldn't be such a task if we had done it right the first time. So basically, my point here is if you do it right the first time, it will benefit you in the long run. And so make sure when you are building your applications that you care enough to abstract how you get the data from how you use it. Okay. Second thing that I've learned as I've gone through and done this is that I have to think in terms of actions. So most of us think in terms of the actions of select, insert, update, and delete, which are the basic 4 things that a SQL database does. But actions move much beyond that. This is how you get data into a data storage system. But this is not how you actually act with data. Okay? The question that I've learned to ask, and Matthew Wiro-Finney has a great blog post on this, a fantastic blog post, and it's largely Zen framework focused, but there's a lot of good stuff in it that informs about how to build models. And he asks this question, what are you modeling? What is it that you're building? And I ask this question of myself whenever I'm trying to build a model because it's the question. It's the thing that I'm trying to solve. It's the problem I'm trying to solve. And I want to know, what is it that I want? What is it that I need? And what does this data represent? So if you're building an application that contains users, and those users are employees of your company, those users have a lot of things associated with them. They probably have a username and a password. That's pretty standard. Okay? They probably have an email address, but they probably actually have more than one email address, a personal email address and a work email address. They probably have more than one phone number. I know I do. They may have more than one work location. If you work for Mozilla, that's not uncommon, or you might be in more than one office, depending on what week or month it is. You might have associated with them their payroll information, their pay stubs, how much you've paid them, when you've paid them, so on and so forth. So all of that information is part of the user, and it's impossible to disassociate from me my phone number. It's possible in a relational database to say my phone number is separate because I might have more than one, therefore those 4 numbers relate to this one person. But you can't take a look at my phone number and say this is a separate piece of data. Okay? So when you're modeling a user or a transaction or anything that you're thinking about when you're modeling, it's not just one table. It's potentially several. It's potentially several data sources. And for several data sources, if you're talking about me personally, you might think, oh, well, he has a Twitter account. And those tweets belong to me. You can't really disassociate me from them. As much as I might like to do that sometimes, they belong to me. They are mine. So we have to ask, what is this thing that we're trying to build a model about? Okay, a good example of where, I work a lot in Django now as well as PHP, and I'll use Django. It's a PHP conference, I'll beat up on Django a little bit. In Django, you have one model per table, and all the methods in the Django template relate to SQL. And take it from me, this sucks, because tables are not models. And if there's anything you take away from this, please take that away. Tables are not models because you may not always be talking about tables. You might be talking about a REST API. You might someday find your data is not really relational and you put it in MongoDB. It doesn't have tables. There's no schema to MongoDB. So don't make this mistake in assuming that you're always going to be working with tables. You're always going to be working one table per model. That's not necessarily how it is. Instead, when I'm talking about building a model, I want to know what is it that I'm doing. So I might need to load a user. I might need to show a user's phone numbers. I might need to authenticate a user. All of those things, loading a user might populate this object, but that user information that I'm populating this object with might come from 5 different tables. The phone numbers come from one table, but it's related to another. This isn't a single table. This is several tables represented as one object and one user. Okay. The third thing that I found to be important is building our applications to be data source agnostic. And what I mean by that is it's important that we use a standard data format throughout the application. In Socorro, we've decided that this is JSON. When a middleware request comes back, it's JSON. It doesn't matter if it talked to Bugzilla and got XML. It doesn't matter if it talked to Postgres and got a result set. It doesn't matter if it talked to HBase and got an HBase result set. It doesn't care. It simply takes whatever it got, turns it into JSON, and sends it back. Okay? And this means that regardless of what the data source is, our application can interpret it because it's JSON. JSON decode is built right into PHP. It's the best function I think has ever been invented, and it works. Okay? And when you decode a JSON object, you get a standard class object. Now, this is where I kind of diverge from Matthew a little bit, and he's talking about domain modeling, because I think these are satisfactory. These are fine for most of what we're doing. I don't care to build an object simply to have an object that's named user or person. Okay? This is probably fine for most of what I need to do. So the standard class object is fantastic. It gives you properties. You can add to it. You can take away from it. You can do a whole bunch of things with it. And if you pass around JSON, or I guess if you want, you can use XML or YAML or whatever format you agree on. If you can convert it into standard class objects, you are gold as far as I can tell. That's been my experience. Sometimes, however, you're going to need custom objects. If you need more methods, for example, a user probably has a lot more things to them than just name, rank, serial number. Okay? You might also want a type hint. This is a big one. You can't really type hint a standard object. It just doesn't work. So if you know that you want to have a particular object and you want to enforce a particular type, you're going to want to go ahead and create an object. But that can just be as simple as class something, open bracket, close bracket, and it's got a name. And that, you can type hint for that. You probably want a little bit more than that, otherwise you're just kind of wasting file space. But it can be that simple. And if you want other methods, by all means, create custom objects. We have several in Socorro. When we get back a crash report, an individual crash report, we have data from HBase and we have data from Postgres, and we combine that data together to produce it, and that we have an object for that. We have an object that represents that. So we do it as well. But for most of what I do, 90% of the time, 95% of the time probably, a standard class object, that's perfectly fine. There's no need to incur the overhead of including a file and instantiating an object when standard class will do. The one thing that I find, even when people do this, is they start expecting things like PDO statement or Mongo cursor. They'll take their data abstraction layer, they'll take their data retrieval layer, and they'll return a PDO statement because it contains everything they want. It allows you to iterate over the result set. It allows you to count the results. It allows you, if you need to do additional things in the SQL, to do those things. But when it comes time to change your data layer, when it comes time to implement a REST API, when it comes time to go from PDO to Mongo, when it comes time to do those things, now you still have to rewrite your code, and you haven't saved yourself any time. And I see this a lot, and I want to caution you against doing this. Leave your data-specific objects in the retrieval layer and focus on a standard data type, a standard, basically standard idea, okay, when you have a standard type when you get outside that layer, okay? The fourth thing that I found that is important in abstracting your data properly is using the correct storage medium. Now, this might seem like a really simple thing to talk about, but it's really hard sometimes to convince people that this is important. So I'll use this as an example. I think everybody in this room, if anybody's familiar with Memcache, would agree Memcache is not really for long-term storage. Maybe if you're Facebook, where they kind of store everything in Memcache, perhaps, but that's an edge case. Anybody who works for Facebook in here, I don't think there is. So, none of us use it for long-term storage. This doesn't create controversy, but this does, for whatever reason. People fell in love with NoSQL databases because they're really, really fast and they do all these cool things and they're not a database and they're easy to set up and you don't have schemas and all this. But relational data still belongs in relational databases. We have to pick the tool that solves the problem that we have, not the tool that we wish solves the problem that we don't have. And it's really important to emphasize this because I see this a lot. people say, oh, well, and I even went through this at one point. I say, oh, well, I have this great idea for an application. I'll build it using Node and Mongo, because those are cool right now. And that's great, more power to you, but applications solve problems. And real-world problems demand real-world solutions, and sometimes those aren't the tools for the job. So using the correct tool for the job is important. Also, as a segue, as an addition to that, choosing the correct NoSQL database is important as well. There are several. We kind of went through this as well with Socorro. We picked HBase, and we set up HBase, and we invested time, energy, money in creating 70 some odd clusters. We spent time, energy, and money in learning how to use HBase, and training the team how to use HBase, and writing our code to use HBase, only to discover we really should have used Cassandra. Now, we've invested an awful lot of time and energy in HBase, and we're not going to change from HBase, at least not in the short term. But I think this illustrates an important point. If we as a team trying to make careful decisions can make that kind of a mistake, I think anybody can do it. We have 70 HBase clusters that do a lot of the things we need them to do, but they don't do everything. They aren't perfect. And when it comes to NoSQL databases, there are a lot of them. HBase, it was painful for us. We had a lot of time to get it stable and to a point where it was usable for us. So when it comes to NoSQL databases, you basically have availability, reliability, and consistency. You get to pick two. Okay? And you have to pick the one that necessarily solves your problem, not the one that meets the cool factor. The other thing that I think people forget about is that there are data storage options that aren't databases at all. They're not NoSQL databases. They're not relational databases. They exist as data storage mediums that are available, but people don't see as data storage mediums. For example, if you have an application that interfaces with Twitter and posts tweets, Twitter is your data storage medium. That might seem a little strange because you can't really retrieve stuff from it, but if your application is designed to post tweets, it doesn't make sense to store that in a MySQL database. It makes sense to post it to Twitter. If you are using some kind of an Amazon service and you are using an API to put stuff on S3 or any of those, that is a data storage system that is not a database. And there are several. There's Elasticsearch, not a database, but really fast to search through, really fast to retrieve results. We've implemented it, it's great. Redis is a key value store, similar to the NoSQL databases, but I think it's different enough. I'm going to call it not a database. There's S3. I store a lot of files on S3. Anybody who's ever used WordPress knows that there's a plugin for caching that allows you to use S3 as a CDN. That's a great storage option, and it's fast and it reduces overhead on the server. I use it on my own blog. And then yes, the file system is still there. It still exists. It's still a storage medium that you can use. Before we had HBase, we were storing stuff on disk. It is available to you. Some of the best caching for WordPress is disk-based. So the file system is a storage medium that most people forget about, but it is there and it does exist. And you have to assume in your application occasionally you're going to want to use a file system. If you ever upload something, you're writing the file system more than likely. But the bottom line is, you can fix it now or you can fix it later, but eventually you will have to fix it. Because when it comes to having multiple data sources, when it comes to having as it comes to having your web app grow, you are going to have to solve this problem somehow, some way. You're going to have more than one data source. If it's not today, it'll be tomorrow. And when you get there, and if you have all of your code in the same place, that is the most unpleasant scenario possible. And I want to warn, so take this as a cautionary tale from someone who's had to deal with this for a couple of years, to change the way that you write code and to change the way that you look at your APIs and take a look at the way that you relate to your data. So, any questions? That was actually pretty quick. So I hope you have, I'm happy to answer any questions you might have.
There's a microphone coming.
Okay.
Is it on? Not yet? Yeah? Oh, cool. So coming back to your first point about data abstraction and with the examples you gave there, why didn't you just use something like the DataMapper pattern?
Why didn't I use something like the DataMapper pattern? I opted not to use any particular pattern when I presented the slides because I wasn't advocating for a particular pattern. I was advocating for not doing something stupid with your code. I don't advocate any given pattern, other than I like to avoid ORMs because I think the one table, one object mapping is a little bit
Absolutely.
problematic.
And it's very relevant to what you were discussing there, that you should have a single responsibility in your model that encapsulates the behavior that your domain is trying to, the problems you're trying to solve with it. And I just thought it was slightly odd that in your model you still displayed an adapter that was getting data, when that should really be two separate things.
Well, that's the pattern that we've kind of adopted in Socorro. So, I mean, there are others, and there are other solutions to the problem. Cool. That's definitely a valid one. So, thank you.
Any more questions?
I think a lot of this depends on what you see the future, isn't it? So how do we map the future, and do we model the scenarios we potentially see? And then I just made the switch from MySQL to CouchDB because I was based on Ubuntu and I'd seen the replication. I wanted to do peer-to-peer, and that was the gut hunch, but it was playing with the future. And how do you grapple with it?
I think predicting the future is difficult. And I don't think anybody in here has a crystal ball. If you do, see me after. Let's talk. But I think in being careful in how you write your code will allow you a lot more options in the future. And that's kind of what this talk is aimed at, pointing out that if you have to think about how you're doing what you're doing. A long time ago, we figured we'd always be on a database, so this kind of one object per table thing worked, and now we're finding out that it doesn't. And it's my biggest frustration with Django, because I have to work with Django a lot in my job, is that if I want to have a model, it has to be a database table, and if I want to model anything else, I essentially have to write it from scratch. I can't adapt it, or I have to install somebody else's plugin. It's not built into the framework, and I think that shows a lack of foresight of things that are coming, while things like Doctrine, which have added some Mongo support, and I think some other NoSQL databases as well, shows some forward support for these ideas. There's no magic bullet to say this is what's going to happen in the future, but I think planning ahead and being careful in how you write your application will help alleviate some of that. Does that answer your question?
It's a tough question. No, it's a tough question. I see the web being more decentralized and more things, so it's getting stuff on the fly and doing stuff.
Yes.
So that's where the modeling metaphor fits perfectly. So because you won't have the choice because it's someone else's service that's chosen to save the username in whatever way.
And I've seen that. I mean, there's a service, I can't remember its name, and there's been some blow-ups about it because of what it does, but it's basically it scrapes GitHub for information, and it's designed to connect developers with people who are looking to hire developers. But GitHub is its data source. that's one of those things about the web that's coming, that's going to be in the future, where you have whole websites as your data source, or whole other platforms as your data source. Facebook is another good example of this. If you write a game for Facebook, Facebook is your delivery platform. So I think, while we don't know what the future holds, I think we can plan for it, and we can be careful and think very carefully about how we construct things. So thank you for your question.
Okay, another question over there.
I'm curious how this influences testing. So if I choose Twitter or GitHub as my data source, how can I actually make sure that my tests will run? Because data can be changed in the remote data source without my knowing it.
So testing remote data sources gets a little bit tricky. If you're writing unit tests, I guess the best way to solve this problem, if you were to ask maybe Sebastian Bergman, would be to mock a data source or disconnect your model in some way from a data source. And when you start dealing with remote data, which we've had some issues with this, Bugzilla goes down, it's a remote data source. How do we deal with that? You have to really test for that. You have to build your tests in such a way that you expect failure, and that you fail, you degrade gracefully. And you have to test for how that process goes, and what's going to happen, what kind of exceptions are you going to get, and things like that. In terms of actually testing it, I think you can do some functional testing. Testing data storage has been difficult for a long time, especially with the web. But I think good functional testing and good unit testing where the data source is mocked up will help you to test those correctly. And that's the other thing, is if you've abstracted properly, you should simply be able to change out your adapter or your data source to some mocked object, and that should solve the problem of not having to connect to things. So, does that answer your question?
Hi. Could you share some of the stats of Socorro and give us an insight to how your infrastructure, what the infrastructure looks behind it, how many instances of the various servers you have, etc.?
Sure, I can give you some basic information about Socorro. I think we do several million crash reports a day. I don't have an exact figure, but every crash report that gets sent to us, we collect and we store into HBase. We have 70 to 80 HBase nodes. We have 5 web heads. We have 2 really big database servers for Postgres. The Elasticsearch servers, I believe we're going to have 6 or 7 of them, and they're being brought online right now. We have, let's see, what else? Our web heads serve as our Memcache servers, so they do double duty. We have 2 middleware servers. We'll probably add a third one. It would be my guess that we'll add a third one. And those are responsible for handling basically all of the data requests. So, and we store all of this in a data center in Phoenix, which is where all the crash reports are. We also have processors and collectors. I think we have 5 collectors and maybe 4 processors. No, we have 7 processors. So it's a fairly large application. And the web piece of it, with only 5 web heads, I think if we were to add it all up, we had like over 100 other boxes that do other things. So it's a pretty big application with a very small web presence. But that's some of the statistics. And we store somewhere between 3 and 5 terabytes of data.
How do you do the write scale across the 2 Postgres databases?
I'm sorry?
How do you scale your writes across the 2 Postgres databases?
We write to one of them, and we use the other one as a backup. So if the first one goes down, then we fail over to the second one.
Yeah, for
So
resilience.
the first one handles most of them. The thing is that we tend not to. So we process the crash. The crash comes in, and we process it. We store the unprocessed crash in HBase. We process it and put the processed one in HBase. We write very little to Postgres. So we have a reports table that contains a list of all the crashes, but there's very little data actually stored in Postgres. Because that data, we don't want to duplicate it, but two, the more data you put in, the longer it takes to write, the bigger your Postgres database has to be, the longer it takes to search it and that kind of stuff. So we write very little to Postgres itself. Does that answer your question?
Okay, one more over there.
How do you deal with latency over your middleware?
So far, we haven't had that problem. The middleware is in the same data center as the webheads, and we actually interface them over the network rather than making an HTTP request outside the network. So we haven't had that as an issue. I imagine that we will. One of the things we've talked about is caching some of those results because they don't necessarily change all that much. A lot of reports we produce on a once-a-day basis. So there's no sense in having that report refresh every time you hit the middleware. So we'll probably extend our memcache option to, right now it's just the webheads. We'll probably install some memcache servers in their own right and use memcache as a solution to that, as well as adding additional servers to augment the ones we already have as more requests come in, because obviously as we're moving to a middleware, we're going to have more requests. The other thing is that those boxes are solely dedicated to the middleware. They do nothing else. So we have a tremendous amount of processing power that allows us to serve those requests pretty quickly. So, good question. Any others?
Hi, did you evaluate many NoSQL solutions before arriving at HBase, and what changed to make you say Cassandra is a better fit?